we going to call it exactly. Oh, cool. It's called rational inequalities. Rational, why? Because look, this is a rational expression. Rational means fraction, remember? And then inequality, because it's not an equation. You see, it's not an equal sign here. It's an inequality sign. So we're going to solve this. So like for number 1, we're going to find what m equals. And because it's an inequality, it's going to be like an interval notation. It's going to be like 0 to 10. All the numbers from 0 to 10, you know, or in negative infinity to 10 or something. Just get on it, yo. You got it. You got it. So maybe I can get you started a little bit. Like number 2. What are you going to do? You're going to factor. The top is okay. The bottom, factor the bottom. Cross out if you can. And then burn the bottom, okay? Get rid of the bottom. And all I have left is m minus 3 greater than 0. And then what's the solution to... Yeah, let me just do one of these, y'all. Yeah, I'm going to do 1 and 2. Let's just finish off 2. So we got m minus 3 on the top. That's okay. On the bottom, the factorization is m minus 4 times m plus 4, greater than or equal to 0. So nothing crosses out. So m minus 3 greater than or equal to 0. Okay. And again, like the solution is what the variable is. So if we just add 3 on both sides, we got m greater than or equal to 3. And that's pretty much the answer, okay? But since it says interval notation, we're going to write an interval notation. M equals the interval 3 to infinity, okay? And you could use the number line if you want. Like if the middle's 0, here's 3. Number line helps you out if you want. It does not really require it here because we don't have a quadratic going on. All right, I am recording, so this will be good. So example 1, here we go. But what are we doing today? So that's the idea. So let's do example 1. Okay. So maybe like writing some steps would always be important. For this one, I said factor everything. Factor. So the top needs some factoring, for sure. X squared plus 2x plus 1, that's an X game thing. That's a quadratic. And so this one, if you factor the top, it'll be x plus 1 squared. Yeah, x plus 1 times x plus 1. Also can be written as with a squared. Doesn't matter. And on the bottom, what do we have? 2x minus 9. That can't be factored. And it's greater than 0. So from here, I can tell you something. Okay, first off, does anything cancel anything? What do I mean by cancel? Does this and this cancel out? No. So, yeah, it's repeating on the top and bottom. So that's why I said number 2 is cancel if possible. Cancel repeats might be okay. But no repeats here, okay. Burn the bottom, I will say is... Burn the bottom is what I say step 3 would be, because that bottom, okay, can, and I'll explain why, can be because
I suck at lying, like damn.
Right. All right, so
Fuck, he's recording.
what? Yeah, jeez. All right, trying to get back. Okay, the bottom can be burned out. And why, like meaning burnout, like why does it disappear? That's the word, right? Because if you multiply everything on the left side by this, won't it cancel out? And if you do that to the right side, what's 2x minus 9 on the right side times 0? So pretty much, if it's 0 on the right side, the bottom just kind of can disappear. Right? Because I'm going to multiply the left side by what's on the bottom, cancels out. And you have to do on the right side as well, but that just stays 0.
You said it can.
Can.
Right? So there's scenario where it can.
This is not 0, you can always do that when it's 0 here. And you should, at least for this section, for sure. All right, so now this is like yesterday, kind of, or not really. Okay, now this is a quadratic graph. It's going to be a U, but what are the 2 points? It's just 0 at x equals -1. So if there's just 1 and you know it's a quadratic, it's going to look like this. Like it doesn't cross twice, it just touches it once. So now look back. This is a quadratic, we drew it. We want the solution is where it's greater than 0. In other words, where it's positive. Where is the graph positive? Just looking at this, is it always positive? Pretty much. Yeah, my gosh. So the answer is -infinity to infinity. It's kind of gross. It's all over the place. I don't know, man.
Mm-hmm.
But I explained everything.
You should do the first example.
First example. I mean, I'll do one more of these examples, honestly. And it's because it's all just like those 6. Okay, so example 2. Factor. P plus 5 times P minus 5 is the top factorization, right? Does anything cancel out? Yes. This cancels out. So P minus 5 less than 0. Wait, this one is not a quadratic. P minus 5, is there a P squared going on there? No. So the solution for P is just solve for P here. And the answer I'm putting over there, I put x equals, write your answer. It's actually P. Shush, please. Thank you. I'm sorry. Or it's like requires some thinking, that's why. I'm sorry. Usually I can ignore it. Don't be sorry. All right, it's all right. Usually I can ignore it and I don't mind and it's not wrong. But
he has to go to orchestra every day. I sit here and listen to you complain about other teachers. I think I should be able to talk.
you're okay, dude.
Thank you.
You're okay.
I know.
I apologize for getting
No,
upset.
don't apologize. Just keep teaching. That's all. He posted on YouTube.
Still recording.
He knows.
Hi, world. Don't forget to like and subscribe. All right, P is less than 5. So that's the answer, really. But it also does go on interval notation, so -infinity to 5. Okay? Yikes. You know, it's just, you just got to get in there and do it, honestly, okay? All right, example 3, factor everything we can. Z minus 4 on top. Yikes. That's a bad example, honestly. I did that bad, because the bottom is not factorable, but you can burn it. Yeah, see...